All right, wizards. So from looking at the work you've done the last 2 days on your blizzard bags, I think the only thing that's kind of left that's giving you guys some problems from time to time is identifying the normal model that you're using in the situation and checking the big enough condition. So our scenario is going to be the same as we used yesterday. The owners of a major metropolitan newspaper believe that 50% of its readers think that the paper should increase its coverage of local news. That is a statement about the population proportion. I believe that 50% of my readers think they should increase coverage of local news. The paper selected a simple random sample of 160 readers from their list of 100,000 subscribers and found that 40% of the sample wanted more local news. That is a statement of the sample. So does this sample provide evidence that the true population proportion of readers who want more local coverage is less than 50%? So let's approach this from a confidence interval point of view. So in a confidence interval point of view, the big enough condition looks like this. In a confidence interval, we place all of our faith and trust in the sample that we took. And in the sample, 40% of my sample said they wanted more local coverage. 40% of the 160 is 64. So 64 said they wanted more local coverage, whereas 96 say that they did not. Both of those, 64 and 96, are greater than 10, which means our sample is large enough to go forward and use a normal model to answer the question. So if we're allowed to use a normal model, what is our normal model? My normal model looks like this. I use the p-hat. I use 0.4. 0.4 times 0.6, remember 0.6 is q divided by my sample size. I use my p-hat to build my normal model, and then I use this normal model to build my confidence interval down here. And that confidence interval is for a 95% confidence interval, where we want the middle 95%. Now the question was, is this evidence that less than 50% of the readers want more local coverage? And in this interval, it appears to be less than 50%, which is right there. So this interval would provide evidence that fewer than 50% of the readers would like more local news coverage. Now let's approach this question from a hypothesis test point of view. The same situation, but in a hypothesis test, we put our faith and trust in the population proportion. That is what we believe to be true. So in the big enough condition for a hypothesis test, I believe the population proportion of readers who want more local coverage is 50%. That's what I believe in. So in a sample of 160 readers, I would expect to see 80 of them who want more local coverage and 80 who do not. So based on these expected values, both of them are greater than 10. So my sample is large enough to go ahead and use a normal model. If we're going to use a normal model, what is that normal model? Down here at the bottom of the page. Here's my hypotheses. The null hypothesis is population proportion equals 0.5. The alternate is that the population proportion is less than 0.5. And the evidence I have against the null hypothesis, this is the evidence I've gathered. The evidence against it is a sample of 160 with a p-hat of 0.4. So I'm assuming this is true. The sample serves as evidence against it. And I want to know, is the evidence strong enough? So I build my normal model. So my normal model is built with the population proportion, but the sample size that I took. And then using this normal model, I'm interested to see how likely is it that I see a sample, a p-hat of 0.4 or less than that, given my null hypothesis is true. So using my normal CDF, I find that probability in the tail to be less than 1%, 0.00571. That is a very small p-value, less than any reasonable alpha level. So I would reject my null hypothesis. I would reject this in favor of this. So I would conclude that the true population proportion is in fact less than 0.5. Now, maybe it's not. Maybe I made a mistake. Maybe I made an error. That is certainly possible. We'll talk more about that if we ever get back to school. But in the meantime, that's addressing the two normal models that you guys were having trouble with, and also addressing the big enough condition. So again, I hope these videos are helpful to you, and I'll see you guys when you get back to school.